Greetings! For today's episode, I had a choice of two items. One is this railroad crossing sign, and another one is this old scope. I had to choose one, and I decided to do the railroad crossing sign because that's definitely more interesting than the scope. Quick backstory on this is I found an arcade redemption game abandoned behind an operator's warehouse. Had been heavily vandalized, all the glass broken on it. And in case you don't know what a redemption game is, it's the kind of game that you put money in and then you use your non-existent skills to pick up things or shoot things down, and then it gives you tickets. And then you go to the counter and you get more useless stuff. Anyway, I was kind of fascinated by this thing sitting out there with all the broken glass. Snow and rain had taken its toll. And as I was looking at it, I saw this sign lying in the middle of the rubble. I carefully extracted this, but I had to repair it because it didn't work. So I gave it a base, I gave it a power cord, and I gave it two red night lights. 7 watts each, incandescent, and come on guys, this is the coolest night. Isn't this the coolest night light ever? So there you have it. We're doing pretty good. Took a minute or so, and I just created the shortest video on record. Nah, just kidding. I picked up this scope along with the scope I repaired to the BK Precision a couple of episodes back. A few of the viewers were a little bit disappointed, myself included, that the BK Precision did not take any real repairs. There she is in the middle of the viewfinder. Basically this scope was non-functional. But after giving it a good cleaning on the inside, cleaning all of the controls, or at least the controls that I could reach, it came back to life. Didn't need any parts. And that was it. But we do want to see some repairs, at least a few parts replaced. And when I picked up that scope, I picked up this one too. This one was even cheaper than the other one because it didn't do anything. Well, not anything is that's incorrect. The power light comes on. It's got a little neon light here, which lights up. But I can't really tell whether the high voltage is running on this. The light's flickering a bit. It messed with all the controls. No matter what I did, I could not get a trace to appear on the display. But what this is, it's a Bell & Howell Schools 9560-1 student's oscilloscope, made in 1974. And the idea here was that a student would buy this as a kit, put it together themselves, calibrate it, check it out and everything, and then go through some course materials that utilize the scope for all of the experiments in there. Now, let's see, it's a 5-inch triggered sweep scope with a bandwidth of DC to 5 megahertz. And I mean, look at this thing, 1970s vintage. The interesting thing is it's not really a Bell & Howell scope, it's actually a Heath IO-102 scope in different regalia. This looks so much cooler than the Heath scope. I mean, even if this thing doesn't ever do anything, I think I'm going to leave it around my workroom just to have a look at it, because if this isn't one of the coolest scopes you've ever seen, you're watching the wrong channel. But let's see what we can do. See if we can get a trace up on this thing. See if it needs a repair, or I just have to spray down the interior again. Hopefully not. But let's open it up and see what gives. I removed the case covers, started to poke and prod, but it was kind of useless because I didn't really know what I was looking for. Now, generally fixing something that a consumer has assembled is a thankless job. We don't know how well this thing was put together, whether we have bad solder joints, whether this ever worked properly, or whether a person in the 70s taught themselves electronics with this and went on to design a famous microcomputer. If scopes could talk, but they can't, so we don't know. But I just checked for obvious things, components hanging off, and one interesting thing I found on this side, of course, is this is a horizontal amplifier over here. Looks pretty normal. I mean, they tried to make it service friendly, I guess. All of the pots are facing front, but some of the pots are way in the back, and the measuring points are the collectors of transistors, which are also way in the back over here. So if you're testing these while they're in the machine, there's a good potential of you shorting something and destroying what you just built. But again, look at the construction here. Things, the variable caps kind of hanging down, and a piece of cardboard insulating it from a control. But the interesting thing is this board over here that wasn't standard fare. It's a proto board with a bunch of chips on it that was added later on. These switches are non-standard. I mean, this obviously is non-standard. It's got a lot of multi-turn pots on here, and I have absolutely no idea what that does and how it may, what its contribution is to the scope not working. Now the other side, so what we have here is on top is the power regulator board. There's a big transformer sitting inside the case here, and this is the vertical amplifier over here. And again, I looked at it, solder joints, the ones I can see, kind of look okay. But I mean, look at this mess of wires. This is usually the dead giveaway that this was built in somebody's basement. And again, I would love to know if this ever worked correctly. Because when you're doing a design, when you're designing electronics, you never really know if your design's going to work. So you prototype, analyze, and figure out what you did wrong if it doesn't work. But generally, when I fix equipment, factory-built equipment, the premise is that, hey, this piece of equipment worked at some day in its life when it left the factory or when the consumer got it. So when you're repairing it, it kind of narrows down your choices. But on something like this that was put together maybe haphazardly, your guess is as good as mine. But let's just assume that this worked at one point in its life and did some useful things. So we're still not getting anything out of it. My poking and prodding didn't do anything. We can turn it back on again. And what we'll see is that the neck is lighting up. So we are getting heater voltage for the neck. So something's working, but there's still nothing on the screen. So I had to go on and take the next step. I downloaded a copy of the assembly manual, and there's a checkout section there. So You put all the parts in, solder everything together, and then you go to the checkout section that gives you basic adjustments so you can see if the thing is generally functional. Then there's also a calibration section, but that the calibration being off generally doesn't mean it doesn't work properly, but the checkout section could reveal stuff. So I decided to go through the checkout section, which is rudimentary adjustments, put all the pots in the middle, check the voltage here and that. And generally this is a kit. This was made for students to learn, so it's laid out okay. All of the trimmer pots facing forward, but you can't even see that, but there's a pot way in the back over here that needs to be adjusted, and the voltage you're measuring is the case of a transistor that's also way in the back over here. So there's a lot of potential here for, if your tools slip, to damage this thing. I just did the basic things, and one thing I noticed was most of the pots both on this side and the other side were either fully counterclockwise or counterclockwise. So somebody had gone in here and just turned pots on it to get things to work. So I did some of the checks, and of course things were off completely, but I did some adjustments for the vertical and the horizontal offsets, and here's the result. So let's apply power and let it heat up. They give you the advice to let it run for about 30 seconds before doing anything, and that's good advice, because you turn it on and you start measuring voltages and they're like jumping all over the place. But things do stabilize. Those paper capacitors in here need to warm up a little bit. As you can see, still nothing, but what I finally found, turning the stability control, gave us a trace. Now again, the trace is oversaturated in the camera, and usually you turn down the intensity and make it look nice on video, but first real defect I found is that the intensity control does nothing. So what I'm guessing is something died in that circuitry, and the CRT is running at full blast all the time. So I guess we can start with the power supply. So after observing everything, I do have schematics, but of course the schematics don't exactly match. So the schematics are of an earlier revision or later revision or whatever, but yeah, there's a lot of guesswork, and you have to measure. You actually physically have to do continuity checks on stuff to figure it out. Well, the very first thing, of course, I saw, there's a cap missing here. It's one of those 0.1 microfarad rated at 1600 volts. And this is part of the voltage doubler circuit. So, I mean, even without it, it can still put up a trace, but does that have something to do with the intensity? I don't know. We won't find out till we actually put a cap in there. So more poking around. It couldn't be that easy. Well, it isn't that easy, you know. Try to find a 0.1 microfarad 1600 volt capacitor. I guess they don't use them too much anymore, and they're kind of hard to find. But I couldn't believe that it was just somebody had, and this isn't broken off, this is somebody has deliberately cut this off. But as I measured around and checked resistors, and we came to transistor Q202, and if we do a diode check between the base and the emitter, if I of course touch the proper terminals, be patient, can't see anything. The base and the emitter are shorted. There's a resistance of what is it doing? I'm doing a diode check here, and it's showing the voltage as 0.001 volts. So that is shorted, just for comparison's sake. Q203, which is the same kind of transistor, measures at regular 0.668 volts forward voltage. So this guy's dead. It's an MPS U10 high voltage transistor rated at 300 volts, and it's sitting right in the middle of the intensity control. So that's why the intensity control isn't working. I'm not sure if that the missing cap is affecting it, but that is definitely affecting it. The part is obsolete, very obsolete, but after a lot of searching I found a modern day replacement for it, and let's replace this guy. Let's change this guy out and put another cap back in here. I have since ordered the parts and they have arrived, and see what happens to our trace. As I was taking out the part, I figured, what if it's something else? It's not necessarily, I mean, if you measure a short, it doesn't necessarily mean that the one you measure a short, the component you measure a short on is influenced by something else. But I lucked out because we got a short showing an ohm. So this guy's bad. Let's bring in the cavalry. So I put in the new guy, and for comparison's sake, you can't really see the body too well. But here's the old one, and here's the replacement. So this one looks like it can absorb more heat. It's a heftier package, but supposedly these things are compatible. I looked at the specs and they're pretty close. Now you may ask, why do I have test clips on the missing capacitor? And that's because I was looking at it and I got to thinking, if the capacitor was removed because it was needed for another project, then it would make sense to not cut off the leads. They just clip the leads. I mean, if you're going to reuse the capacitor, then you're going to need to desolder it from the board so you have the full lead length. But if you look at it, there's quite a bit of the lead left, which means it was cut either in anger or with an urgency to expedite this thing. So I was thinking that maybe there was a reason for the former owner to just cut this thing out, and before soldering it in, I should probably test it. I fired up the function generator, hooked it up, and let's see what we get. For now, the vertical selector is on ground. So let's just see if we get a trace, and what happens then. Well, so far no trace. Well, there you go. Alright, see, it's very dim because our intensity now works, except I guess the transistor is not fully compatible with the old one because there's only a very small arc on the intensity adjustment that actually works. So see, it goes up and then after that, this is about full intensity, and we're up, what, a quarter. No change after that till we hit that again. So as you can see, very small arc of effect, and that probably has something to do with the transistor not being, the beta of the transistor is probably different, probably much higher than the original ones. And also we have a lot of old capacitors in here, which are probably dried out. I mean, they tout this as the solid state. It's probably one of the first generation solid state scopes, cheap scopes that were made available to a larger audience. And because of that, I mean, these caps are old, and that's probably affecting it. I mean, we do have control over the intensity now, so, but we just have to be aware of the smaller area of effect. The cap is over here. Excuse me, I don't want to short it to anything, but it's simply clipped on over here. And just looking at the, we're set to ground, removing the cap doesn't make any difference at all. So let's get the function generator signal into this. And that was a real joy, because I sat here for a while, and whenever when I put the input, oh, it's an input operate right now, which means it looks at what's being piped into it, and it wasn't working. And then I start playing with the mystery switches over here, and I guess this one didn't do anything. Oh, but we're still in ground. So now, see how there's a brightness gradient from left to right? Most likely that's also a capacitor. But the missing capacitor, which was put in, was disconnected. And if I connect this, there's really no difference here. Let's see, you can see the gradient from left to right. And if we disconnect this, it gets a little brighter. See that? So it has a little difference, but I guess the advice given out at the time was just snip out that capacitor and you'll get better consistency across the screen. So the picture is not too bad. It's not fully consistent across. This is the focus control. Another thing you have to realize is this is an old and inexpensive scope, so the conveniences we are used to today, that gradients like that, or adjusting things, or switching inputs, doesn't really affect operation that much. It's a whole different ball game on this one. Let's see, if we go back to ground, I got it adjusted just right, so when you're going back to ground you actually see the trace, and then you change the vertical amplification and you actually see a full screen of data displayed. But it's not that easy. If you start messing with the controls and you change things, for instance, here's a stability control, which I guess is some sort of trigger something. All sorts of weird things happen. And again, I think I would attribute that to old components. This thing needs to be completely recapped and then gone over, and then it needs to be calibrated. But a basic proof of concept, hey, it works. So let's switch to a triangle. There's your triangle. Unfortunately, the peaks look like the snow has eroded the peaks or something like that. Again, calibration. And if we go to a square wave, we get some really bad overshoot at the whenever it switches states. That's what it looks like here. And there you have it. That's usually something you would compensate a probe for, but I can't compensate it because I just got a BNC coming in from the function generator. And yeah, that's it. Proof of concept, or the idea of this video was, can we bring this guy back to life? I don't think anybody ever imagined or expected this to get to a point where it actually becomes a useful day-to-day lab instrument. It will never be, and I'm sure it never was when it was new either, but it's working. And let's see, what else do we have here? Oh, our little dancing sine wave, which you saw last time too. It does that. So what I think this would be, what this would do really well at is, I'm probably going to turn this into a scope clock, because you know it's XY compatible, and see what the clock looks like, and then maybe go in and replace capacitors in it. That's not very high on my list right now. I think we achieved our purpose of showing that this thing works. What we need to find out is that proto board. Let me get this capacitor out of here before I shock myself. What I'm really curious about is that proto board we saw on the inside. I could find no information on it whatsoever, which means in order for me to find out what it does is I would have to remove it and essentially draw a schematic for it, especially with the 4 multi-turn pots there. I'm not exactly sure. I would have to look into, first of all, the first clue would be how is it hooked up to the existing controls, and then of course, I mean, there's just TTL chips on there. Shouldn't be that hard to make a diagram, but that's well beyond the scope of this video, and maybe I'll do that on a long snowy night sometime in the near or far future. But I still think the scope looks really cool, especially with the side panels on, the color scheme and everything. And maybe I'll just put the dancing sign on it and have the dancing sign play. But yeah, if I find a scope clock and this actually shows it, we'll do another episode on that. And the scope clock is kind of, I have quite a few scopes now. Quite a few of them are more of historical value than anything else. They're useless for lab work. But if I find a good scope clock, I'll just make a row of scopes that display the time. And another proof of my nerdhood. Thanks for watching. Please like and subscribe. Leave me a comment. And we'll see you next time.